Hi, this video is going to discuss both typical shape indifference curves and atypical shape indifference curves and provide you some intuition on the shape of curves in these different situations. So for the convex curve, or what we think of the typical case, consider two goods like burritos and pizza. This indifference curve is smooth, it's downward sloping, and in this case, all these bundles, A, B, C, and D, the consumer likes equally well. Most goods have this typical smooth shape. Now, consider the situation where we have special cases or atypical cases. In this case, goods, the two cases that we will go over, are perfect substitutes, where goods for the consumer is completely indifferent between which ones they consume, or perfect complements, goods where the consumer is only interested in consuming them if they can do so in fixed proportions. Let's go over both of these situations. First, the atypical case of having perfect substitutes. So maybe it's Coke and Pepsi are the perfect substitutes for you or for Bill. And if these are perfect substitutes, if Bill likes one Coke just as much as one Pepsi, how would we mark that indifference curve? Well, consider the case where Bill has one Coke. Well, Bill is, if you've used that one Coke just as good as one Pepsi, then you could simply draw a straight line connecting this one Coke, no Pepsi with one Pepsi, no Coke. That's a first indifference curve. A second indifference curve for Bill would be two Cokes, no Pepsis, or two Pepsis, no Cokes. So again, Bill likes Pepsi and Coke equally well. Bill doesn't care if he's got a Coke in his hand or a Pepsi in his hand. And a third and fourth indifference curve would look as follows. All of these have the same slopes, they're all lines, and they all go from one intercept to the other intercept with the same number as each. Now let's do the other extreme case of perfect complements, goods that are only used if you can consume them in fixed proportions. Examples of this may be a car with 4 tires and 1 engine. Every engine you have, you need 4 tires to go with it. A car doesn't do you any good if you don't have 4 tires. Additional engines don't do you any good if you don't have additional tires. So, here in this example, we can consider Sue, who only eat a piece of pie if she can have a scoop of ice cream to go with it. For me, it would be like breakfast cereal and milk. I will only eat a bowl of cereal if I have milk to go with it. But for Sue, she likes 1 piece of pie with 1 scoop of ice cream. So, in this case, bundle A would be the intersection of 1 ice cream scoop and 1 slice of pie. And note, for Sue, additional scoops of ice cream without additional slices of pie make her no better off. So Sue is indifferent between bundles A and bundles D. Okay? Likewise, bundle E with 3 scoops of ice cream and 1 slice of pie doesn't make Sue any better off either, under the perfect complements extreme. So these perfect complements are right angles that intersect at the optimal combination of the two goods. So that's one indifference curve for Sue. A second indifference curve for Sue includes 2 scoops of ice cream and 2 slices of pie. Once again, additional scoops of ice cream, if she only has 2 slices of pie, does not improve Sue's welfare. In a similar fashion, additional slices of pie with only 2 scoops of ice cream also doesn't improve Sue's welfare. So this is the shape of perfect complements indifference curves. So here's a third one as well. So let's summarize then this situation. We have perfect complements, which are right angles, when you are like Sue and only will consume the goods in fixed proportions. We have perfect substitutes, where these are lines going from one axis to the other axis. And then you had the typical shape here in pink of a smooth downward sloping thin indifference curve. So every good bundle between two goods will lie between one extreme, the other extreme, or something in between, which is a typical shape. So this is an example of a convex indifference curve, here in pink, and extreme shapes that are either perfect complements or perfect substitutes.